Yes. This is 1.3, and the assignment is going to be on page 37. It's just 1.3 because there's not another section. We're just going to do all of section 1.3 together and be done with it. Okay. Now, these properties you're going to have memorized. Okay. So the first one we have to talk about is the closure property. And the closure property just says for any real number, when you add the numbers together, you're going to get a real number. Now, that seems silly that you would have to say that, but remember, we're only dealing in the realm of real numbers right now. And later, we're going to go on and deal in the number that are imaginary. So if you have real numbers, so if A and B are real, then when you add A plus B, then the sum is the answer when you add two numbers together, is a unique real number. That's the definition of closure, which kind of makes sense because if you plant a pumpkin seed, you expect to get pumpkins. That's closure. If you add real numbers, then you should get an answer that is real. So that's all closure is saying. Okay? Same thing with multiplication. If you multiply two numbers together and get that product, then the product is a real number. So it seems kind of silly right now because we haven't really dealt with anything other than real numbers. But for all of the rules to work in math, we have to state that. Okay? And you do understand that adding a negative number is the same as subtracting, so that A plus the B, the sum is covered with subtraction, and multiplying by the reciprocal is the same as dividing, so that takes care of add, subtract, multiply, and divide. So if you do an operation with real numbers, then your answer is going to be real. Okay? That's closure. Now, commutative. Do I have anybody in here that commutes to school? Do I have anybody in here that drives to school? You're a commuter. You're driving back and forth. That's what commutative means. So the commutative property for addition says that if A plus B, then it's going to be B plus A. We have just swapped positions. And for multiplication, it is just the positions have been switched, swapped, commuted. Okay? 2 times 3 is going to equal 3 times 2. And we can say that because of the commutative property of real numbers. Now, the associative property, says that for A, B, and C are real numbers. Okay, so these are all under real. So I'm not going to state if A, B, and C are real numbers because we are in the set of real numbers. If I multiply, and I'm just going to put parentheses around these. And if I have A plus B plus C, or if I have A plus B plus C, it's the associative property. Now, notice there are 3 numbers involved in each of these cases, not 2. Everything we've dealt with up to this point has had 2 numbers. The associative property is grouping. So ABC, ABC, they stay in the same order. A plus B plus C, A plus B plus C. What has changed? The grouping symbol. Yeah, what's grouped together. So when you are looking at, is this the associative property or the transitive property or whatever the property, look to see, are the letters in order? And did you just regroup? If you regrouped, it's the associative property. Okay? Does anybody know the identity for addition? What does identity mean to you? Nobody? What is your identity?
Who you are.
Who you are. Okay. So if I have a number 5, what can I add to that number and not change its identity, that it stays 5? So if you have a number and you add 0, we say that's the identity property for addition because we are adding. Okay. And that's going to be the same if I put 0 plus A, right? It doesn't matter in what order I add the 0 and the A. What number can I multiply and it not change the value? So we say that 1 is the identity for multiplication because we haven't changed the value of it. Now, here's where things get a little bit dicey. If you are adding 0 to the number and it equals the number, that's the identity. If you are adding a number to A and you get the identity, I'm at 5, how do I get 0? We're going to add that -5 or subtract 5. Okay, this being adding and subtracting is called the additive inverse. And you've used the idea of the inverse all the time, and you may not have known that that's what it was called. But the inverse takes you back to the identity. Okay, so then if the additive inverse, adding the negative to it, the opposite, gets it back to 0, then what would I have to do with multiplication? What would be the inverse for multiplication?
Divide.
So we have to have it equaling 1. If A is my number, then I'm going to multiply by the reciprocal, which is the same as dividing. Multiplication and division are inverses of each other, yes. Yes, 1 over A times the A is the same as A divided by A. It gives you the same thing. Multiplying by the reciprocal is the same as dividing. They mean the same thing. And that's why I showed you the little trick when you had that 3/5 times 5/3 business. And I said, well, you can just divide out those numbers first and then multiply straight across. Because you're really dividing if there's a number on the bottom and get the smaller numbers. And I think by using the calculator, most students don't realize that fact. Dividing is the same thing as multiplying by the reciprocal. All right, did everybody get these? We have a few more, just a few more that you have to have memorized. All right. So you have to understand that mathematicians are not creative. Okay, they're not creative. We're going to multiply. So what is my operation? If I'm multiplying, what is my operation? Not a trick question. Multiplication, it's multiplying. Okay, so multiplication property. So I'm multiplying multiplication property of 0. What am I multiplying by? 0. So if you are multiplying by 0, that's the multiplication property of 0. And a number times 0 is equal to what? 0 times any number is 0. Yeah. And here's another one. We've got the multiplication property. So what operation am I doing? Multiplying. And what am I multiplying by? -1. Yeah. So the multiplication property of -1. So if I have a number and I'm multiplying it by a -1, and -1 times a is that commutative property, then what am I going to get? The opposite of what it is. Yes. The opposite of whatever it is. So if you're multiplying by a -1, you get the opposite number. So here's an example. I'm going to let a be a -2. If I multiply -2 by a -1, then my answer is the opposite of the negative, which makes it a positive. All right, and then we're going to talk about the last one. So this is going to be a little bit long. It's the distributive property, and this is the one that you've probably called it the distributive property and used it a lot. The other ones you've probably used them and not called them by name. But what does the distributive property mean to you? Yeah, it distributes over multiplication and division. So you're taking your first number and you're multiplying it by everything in parentheses, distributive property.